In physics, you studied that electricity flows only when there is a closed circuit. Let's look at this setup. In this, we have a battery. There are two metal rods. The first metal rod is connected to the positive end of the battery, and the second metal rod is internally connected to the negative end of the battery. And the bulb is connected to the battery. So the bulb will glow only when electricity flows through this circuit. That is, electricity will flow only when there is a closed loop. In this case, we see that the bulb does not glow. This means that this circuit is not complete. Now, let's join the two metal rods. When we connect or join the two metal rods, we see that the bulb glows. What is happening here? We see that now the circuit is complete. It forms a closed loop. And what happens in a closed loop? In this end is negatively charged. This metal rod is negatively charged. This is positively charged. So when we connect the two metal rods, this negatively charged rod, which had excess of electrons, passes the electrons to the positively charged rod. So there is flow of electrons, and electricity is passed only when there is flow of electrons. So now in this closed loop, there is flow of electrons. So it forms a closed circuit, and we see that the bulb glows. Now, let's take the original setup. So in this case, we are not connecting the two metal rods. There is no closed loop formation, so the bulb does not glow. Let's take an empty beaker. We take an empty beaker. We immerse the two metal rods in this empty beaker. The bulb does not glow. Let's add some solid salt to this beaker. Now this time we have added some solid salt to the beaker. The bulb does not glow. That means electricity is not flowing. Now let's add some water to the solid salt. So in this case, we have formed salt solution. So when we form the salt solution, we see that the bulb glows. What happens here? Why is the bulb glowing? Why does solid salt does not conduct electricity, but salt solution conduct electricity? What is happening inside the salt solution? For this, let's see the structure of salt. So we have the solid salt. If you look inside, it's made up of NaCl crystals. And this is how the crystal arrangement is. When we add it in water, the sodium and the chloride ions separate out. Why do they separate out? Let's see. So this is the sodium chloride crystal. The sodium ions, that is Na+, they are positively charged. The chloride ions, Cl-, so they are negatively charged. When we add it in water, so we have the water molecules. We know in water molecules, there are two hydrogen atoms and one oxygen atom. The two hydrogen atoms are slightly positively charged, and the oxygen atom is slightly negatively charged. This is because the electronegativity of oxygen is more. It tends to attract the shared pair of electrons towards itself. So oxygen is slightly negative charged, and hydrogen atoms are slightly positively charged. So let's see, when we add the sodium chloride crystal to water, what happens? As the hydrogen atoms are slightly positively charged, they take away the chloride ions. And as the oxygen atoms are negatively charged, they take away the sodium ions. So this process continues until all the sodium ions and chloride ions separate out. So now, when we have the salt solution, the sodium ions and the chloride ions have separated out. So let's see what is happening inside the solution. Since this rod is positively charged, this is negatively charged. So the negatively charged ions are attracted towards the positively charged rod, and the positively charged ions are attracted towards the negatively charged rod. So we see that the negatively charged ions accumulate on this metal rod, and the positively charged ions accumulate on this metal rod. So now we see that the bulb glows. Why? According to physics, we know that the electricity flows only when there is a closed loop. So how is a closed loop formed in this situation? Let's see. When these negatively charged ions accumulate on this metal rod, in order to become neutral, now both the negatively charged ions and the positively charged ions, they tend to become neutral. So when these negatively charged ions, they tend to become neutral, they give away the excess electrons to this metal rod. So by doing this, they become neutral. Similarly, in order to become neutral, the positively charged ions, they take electrons from this negative metal rod. So now they are taking the electrons from this metal rod in order to become neutral. So what do you observe? A closed loop of electrons is formed. Since a closed loop or a closed circuit is formed in this case, we observe that the bulb glows. This means that electricity is flowing through this solution. So we see that in salt solution, due to the formation of ions, there is flow of electrons. It leads to the formation of a closed circuit and we see that the bulb glows. What was happening in solid NaCl? Solid NaCl does not allow electricity to flow. Why? This is because in solid NaCl, the sodium ions and chloride ions, they are not free. They are strongly attracted towards each other by the electrostatic forces of attraction. And therefore, they cannot separate out. Ions cannot be formed and so they do not allow the passage of electricity. Let's do a question here. NaCl conducts electricity in the solid state. Is it true or false? So when we have NaCl, this compound, that is sodium chloride, in the solid state, the sodium ions and chloride ions, they're strongly bonded to each other by electrostatic forces of attraction. So the sodium ions and chloride ions are not free. They do not form separate ions and so they do not conduct electricity. Now we know that when we take solid sodium chloride or solid salt, there is no flow of electricity, so the bulb does not glow. Now let's heat the sodium chloride. When we heat the solid sodium chloride, it changes into the molten state and what do we observe? The bulb glows. What is happening in this case? When we heat sodium chloride, we know that the sodium ions and chloride ions, they are attracted towards each other by electrostatic forces of attraction. But when we heat this, these forces of attraction get weakened. So the attraction is lost by heating them, that is by increasing the temperature, and by this the sodium ions and chloride ions separate out. So now when the two ions separate out, again there is ion formation. The positively charged ions, they migrate towards the negatively charged rod. The negatively charged ions migrate towards the positively charged rod. There is flow of electrons and so electricity flows. So from these experiments, what have we observed? We have seen that NaCl conducts electricity in the aqueous state or in the molten state. But it does not conduct electricity in the solid state. And we know why. This is because in the aqueous state or in the molten state, there is formation of sodium and chloride ions. But in the solid state, the sodium and chloride ions are strongly attracted towards each other. They are not free. And so the ions cannot separate out. So solid sodium chloride does not conduct electricity. So we can conclude that ions are required for electrolysis to take place.